Today we're looking at lesson 4.2, which is talking about specifically the angles of triangles. This is for geometry. So we're going to start with the theorem that is mentioned in this lesson, and that is the triangle angle sum theorem. We touched a little bit about this today, but when you're thinking of the angles of a triangle, they will always add up to 180. So that is what this theorem is stating. Something to just note in terms of a vocabulary word is an auxiliary line, which I've pointed to here. Sometimes you might need an auxiliary line to find different angles. So it's just an extra line or a segment drawn anywhere on the vertices of any of the triangles to help you find the angles that are inside the triangle. So for the first example here, you are going to find the measure of each numbered angle. So we have angles 1, 2, and 3. Based on the fact that your angles of a triangle need to add up to 180, let's start with angle 2 on LKM, triangle LKM. So we're given 2 out of the 3 angles. So if we add those up, we have 57 plus 71, which gives us 128. And since we know that the angles of a triangle need to add up to 180, we're going to subtract 128 from 180, and that's going to give us 52. So our third angle, which is actually labeled as angle 2, is going to be 52. Now, if we go to the first triangle, JKL, 2 out of the 3 angles are not given. But if you look at angle 1 and how it's written, this is actually a linear pair because we have a straight angle, which equals 180, with segment JM. And if we subtract 180 minus 57, which is the other side of the linear pair, we're going to get angle 1. So 180 minus 57, that's going to give me 23, and that is going to be angle 1. Whoops. So if that is angle 1, we can go back, fill in 23 degrees as angle 1, and now we have 23 and 28 in triangle JKL. We can add that up, subtract that from 180 to find angle 3. So 23 plus 28 is going to give us 51, and we're going to subtract that from 180. So that's going to give us 129. So that is angle 3. I just realized that I did something a little bit off. I did 180 minus 57, and I forgot that it should be 123. Whoops. So if we do 123 plus 28, that gives me 151, and I'm going to subtract 151 from 180, which is going to give me just 29. And I know not to assume usually, but there was no way that it looked like angle 3 was an obtuse angle just by the way that it was drawn. So that made me think, okay, I must have done something wrong here. So it actually should be an acute angle, which now makes sense if it's 29. And angle 1 does look like more of an obtuse angle. So that should make sense to be 123. Oops. Okay, now we have another figure, and we're going to be kind of doing the same thing. We can start with whatever looks the easiest to find here. In my opinion, I would start with triangle XYZ because, again, you're given 2 out of the 3 angles. So if you start with that and find angle 7 first, I would add 58 plus 65. Which gives me 123, and then subtract that from 180. And that will give me angle 7, which is 57. So now I have angle 7. And that's 57. Now, if I remember back in the first couple of chapters we did, vertical angles are congruent. Notice that angles 5 and 7, which are formed by two intersecting segments or two intersecting lines, are vertical. So that would make angle 5 also 57. Now, again, we have two angles out of the three for triangle XVW. So we can add 57 plus 67, subtract that from 180 to get angle 4. So 180 minus 124 gives me 56 degrees for angle 4. So now we need angle 6, 8, and 9. Now, angle 6 and angle 7, or angle 5 and angle 6, are linear pairs. So we can do 180 minus 57, since angles 5 and 7 are the same. And that will give me angle 6, which is 123. And since they've labeled angles 8 and 9 as the same, we're going to kind of use a variable here. Let's say they're both x, and put them all equal to 180 for a triangle WXZ. So we have x plus 123 plus x, or 2x plus 123. And we know that it has to equal 180. So now we're just going to solve for x. So that gives me 2x equals 57. And if I divide, that's actually going to give me a decimal, but that's okay. So I get 28.5 degrees. And since both angles 8 and 9 were x, they're both going to be 28.5 degrees. Now we're going to talk about angles that are outside of the triangle, which are called exterior angles. So inside the triangle, they're called interior angles. Outside the triangle are called exterior angles, and there's a theorem that relates to exterior angles. So they're saying in this particular example, angle 1 is here. That's an exterior angle. So angles A and B, if we're given those, if we add those up, that will equal angle 1. And that's a theorem that we need to know to find exterior angles. So here's an example of an exterior angle, angle 1, in this mounting bracket. So Tanya mounts the shelving bracket shown to the wall of her closet. What is the measure of angle 1? The angle that the bracket makes with the wall. So this right here. Now it gives us the angle 40 degrees and 90 degrees with the right angle symbol here. And these are located across from angle 1, so they're called the remote angles. So if we use the exterior angle theorem, it says that the two remote angles add up to be the same as the exterior angle. So if we add 90 plus 40, that gives us 130, and that is actually going to be our exterior angle. This is a side note. This is another kind of proof that we're going to try, and we're going to get into more proofs for this lesson, or for this chapter, in the next couple of lessons. But we've done a 2-column proof, which I usually stick to. We did a paragraph proof. Now we have what's called a flow proof. I just want you to know what it kind of looks like. It's kind of like a web, where The arrows are kind of just haphazardly coming from the given, but you're always going to obviously still start with the given. So this would be the reason that the given is, and then you have each each reason is below each statement. So these are all statements in here. And then finally you're going to have your proof statement and the reason underneath that to end your flow proof. So it kind of, like I said, flows like a web. Again, this is a preference that you can use. You can use a flow proof, you can use still a two-column proof, you can use a paragraph proof. As long as you have your given, your reasons to get to your proof, and your proof in the proof, then you should be fine, no matter what way you use to set it up. And then the last part that we'll look at is they're calling these corollaries. A corollary is a type of theorem, but it says it's a theorem with a proof that follows as a direct result of another theorem. So we're using another theorem to get this corollary. So it's not a theorem on its own, it's based on another theorem. So that's what a corollary is. So it's a type of theorem almost. So there's two corollaries here. One is corollary 4.1, and they call this the triangle angle sum corollary. It says the acute angles of a right triangle are complementary. So if we remember what complementary means, that means that they add up to 90. And then you have another corollary that is related to triangle angle sums. And that means that there can be at most one right or obtuse angle in a triangle. I actually mentioned that today in the lesson. But that's a corollary. So we're going to use those, keep those in mind for this last problem. And we're going to try to find angle 2, angle 3, and angle 4. We can actually use the methods we were using with the last couple of examples, or actually the first couple of examples, to come up with the sums here of the triangle angles. So if we're going to start, we probably want to start with triangle TZY because we're given 2 out of the 3 angles. So that gives me angle 1. It actually doesn't ask for angle 1, but let's find angle 1 first. So if we do 52 plus 90, because this is a right triangle or a right angle symbol, we're going to do 52 plus 90 and subtract that from 180. So that gives me 38. That's going to give me angle 1. Now, since 3 of these angles here in this figure are right angles, that means we can assume that the 4th angle right here, angle T, is going to be a right angle. So if we have 38 plus angle 4, that's going to be equal to 90. So 38 plus x has to be 90. So that's how we're going to find angle 4. So that gives me 52 for angle 4. Now, if we go to the next angles, if angle 4 is 52, angle 3 is going to have to equal something but we don't quite know yet. And then look at across from the right angle. On the other side of the right angle, there's always another right angle symbol. So that's actually going to give us 52 plus 90 again, which makes angle 3 38. And if angle 3 is 38 and we need to make it equal to 90, angle 2 has to be 52. So you can kind of go around in a circle, square in this point, to come up with your angle measures. And that concludes lesson 4.2 for geometry.